Hello, today we're going to be making solutions and dilutions. First, we're going to make a 250 milliliters of a 0.02 molar copper 2 sulfate solution starting from the solid hydrate. So we need to calculate how many moles we need first. So I will need to change milliliters to liters. 250 milliliters is 0.250 liters. And liters times molarity will give us moles. And so when you multiply there, we have 0.005 moles of our copper 2 sulfate. Now, because there is just one molecule of the CuSO4 for every hydrated compound, I can assume that the moles of CuSO4 is the same as the moles of the hydrate. Moles of the CuSO4 pentahydrate. Because this is how I have the compound as a solid, it's a hydrate. Now I can change moles to grams using the molar mass, 250 grams per mole for that hydrate. And so you'll get 1.25 grams when you multiply, and that's how much of the solid CuSO4 pentahydrate you will need to measure out. Okay, so the first thing we do when we're making the solution from a solid is we need to weigh out the correct mass that we just calculated. So I want to use my weigh boat and zero or tare, and then I'm going to measure out the 1.25 grams. Now, you can see these copper sulfate pentahydrates, the chunks are really big, so we might not get exactly 1.25, but we're going to hopefully get pretty close. That's a little too far. That's much closer. Okay, so we've got our correct mass, or as close as we can get, and then we want to transfer that into the correct size volumetric flask. So since we're looking for 250 milliliters, I want to make sure I use a 250 milliliter volumetric flask. These are very, very accurate to one volume, but I can't measure anything less than the 250 milliliters. Okay, so once you have your solid in the volumetric flask, you're going to add deionized water, and you want to add it while stirring. So for the first volume, I'll usually pour because there's a lot of space in here, so I will usually pour some in. But you need to be really careful, because if you go past the line ever, then you'll have to completely start over, because there's no way to take out just the water molecules once it starts dissolving. Right. And then we need to make sure that we're stirring. And you want to get a lot of it to dissolve before you move on to the next step, which would be to completely fill to the line with water, which you also want to do while stirring. Good. Okay, so to finish making up your solution, you're going to, again, make sure that the volume is completely up to the line, and so that the bottom of the meniscus is right at the line there, as close as you possibly can get it. And then you might want to give it a final stir, but then your solution is complete. Okay, so for our second part, we're going to make a dilution. We will be starting with the 0.02 molar stock solution that we created from the solid copper 2 sulfate pentahydrate. And we want to make 100 milliliters of a 0.01 molar solution. Notice how the molarity is decreasing. So we're doing a dilution here. Anytime we're diluting something, we're adding water, but we need to calculate how much. So you're going to use the dilution equation, which is M1V1 equals M2V2. So we're looking for a solution that has 0.01 molar and 100 milliliters. And my stock solution that I'm starting with is 0.02 molar. I need to solve for V1 to figure out how much of my stock I need to measure. So you'll multiply and divide. And when you do, you'll see that you'll need 50 milliliters of my 0.02 molar stock solution. So this is how much that we will need to measure from our stock in order to make 100 milliliters of solution. All right, for the next experiment, we're going to make 100 milliliters of 0.01 molar copper 2 sulfate. So we're starting off with the 0.02 molar that we just created, and we need to transfer 50 milliliters of this into our 100 milliliter volumetric flask. So there's a couple ways that we could do this. You could use a burette, so you could put some of this into a burette and then dispense out 50 milliliters from the burette. You could use a graduated cylinder, but graduated cylinders tend to have a lower precision. You could use a graduated pipette like this one, which has markings on it. This one is really small. This one's only like a 5 to 8 milliliter pipette, and so it probably will not be an efficient way to transfer that. Or you can use something called a volumetric pipette, which is this one here, and it measures 50 milliliters at that line at the top very, very accurately. So what I want to do is draw up 50 milliliters from my volumetric flask. So I will put this in here and then attach my pipetter and draw up
I remember this.
all the way to the line so that it's exactly 50 milliliters. And then I can transfer this over to my 100 milliliter volumetric flask and release the 50 milliliters down. Now, it might be a good idea when you're preparing to use a volumetric pipette like this to clean it as you would a burette. So if you rinse it with deionized water first, then rinse it with your solution, and then fill it up with the solution. That way you will remove any effects of the excess water that's present. All right, now that I've transferred all 50 milliliters over, I can add deionized water while stirring. Now remember, if you're doing an acid solution, you always want to have water in your flask first and then add the acid in. A lot of people use the mnemonic A&W root beer for that, so you always put acid into water. That's because the reaction when the water is dissolving is very exothermic. So having the extra water in there can help to absorb some of that heat as it's dissolving. But in this case, since it's just the copper 2 sulfate, it was okay for us to put the substances first and then add the water in. Just like before, you want to really slow down when it gets close to the neck, and make sure that you're not getting too close to the meniscus, because if you go too far, you can't go back. So adding just a tiny amount at a time so that the bottom of the meniscus is right on the line.